So let's move. Okay, and I'm going to give you some examples. So we are going to have all of basically this combination. So first of all, I'm going to introduce you. Okay, from the first approach, I'm going to write to a text file. Okay, so this is the first approach, writing to a text file. So this is your example. Okay, as so we said, so we need a file and then passing the fptr, so f open, and so we need to pass the basic. Okay, if I don't specify any path here, it means that the current working directory. Okay, so here I mean that, okay, text.txt. Okay, this is a text file, and I'm going to write. So I'm check here for error handling, and then okay, so I receive some things from the user by a scanf function, and finally I'm going to basically write it to the fptr. This fptr is basically here, so it's a return value from the fopen, and I pass to the fprint function, and so I specify this is an integer value and this is the number I'm going to print into the file. Okay, and then finally I'm going to close fptr, and then everything is finished. Okay, so let's run. Writing to a text file. Let's see. Okay. Okay, so I'm going to write the text file. Okay, so I specify a number, for example 22. So as you can see, I have now a text file, and the inside is 22. Okay, so this is the first approach. And in the next step I'm going to introduce it. Okay, with the first approach I'm going to read now from a text file. Okay, so again, okay, I forgot to say that, as you can see, I include the stdlib.h. Okay, and okay, I need to introduce the file star fptr and then fopen. So I pass the text file test.txt, and so I'm going to read. So this is the error handling, and then fscanf from the file, and then okay, so this is only an integer value, and then I print out the value, what is value inside, and then so I'm going to close the file. So let's use the previous one. I'm going to read. Okay, so I'm going to this time reading from the text file. A1 R. Okay, so as you can see, basically read the number 22.
GCC is to run the file, the C file.
Okay, so GCC. Okay, so you don't know GCC?
Is a compiler.
Yes, GCC, or maybe yeah, GCC is the compiler inside the. You can use it inside the Linux operating system. Yeah.
And the O option.
Okay, the O option is used that. Okay, so if you use GCC without any -O option, so you pass your basically here you pass your C code, and then if you don't specify -O and name, so the output binary file is just a.out. Okay. But if you are going to store it with a meaningful name, so you can specify -O and then you specify a name for your compiled file, the binary file that after compilation you will receive. So this is the name basically. So it means that okay, so here the interpretation of this line, it means that okay, by GCC I'm going to compile this file and I'm going to store the binary file of this compilation inside to a file that is A1RT. Okay, but as I said, so if you remove this part, so the binary file will be stored in a file that is a.out. Okay. Okay, so this is the first step, and then I'm going to introduce you the first approach, writing to a binary file. Okay. Okay. So here, in order to write to a binary file, first of all, I introduce a structure. Okay, so this structure, it has basically 3 integer values. Okay, and then here, so again I need the fptr, and the data type is file, and I'm going to use fopen in order to open up a file. But if the file doesn't exist, so it tries to create that. Okay, so test.bin, and I'm going to write to a binary file. Okay, and then I store it here, the output from the fopen, and finally here, so the n value is from 10,000 to 10,009. So I'm going to, first of all, okay, so the num n1, okay, so as you can see, I introduced the struct num, so the value that is the variable that is called num, and then so the n1, n2, and n3, so we can see that the first value is n, and so 3 times of n, 3 times plus 1 of n. So I'm storing in these 3 basically variables. And then finally I'm going to use fwrite function in order to store the content of this struct inside the binary file. So as you can see here, so the last value was fptr here, and so I need to say that how many blocks that I'm going to write. So I'm going to write only 1 block, and in 1 block that I'm going to write, how much data I'm going to write. So this is basically the size of the struct that I introduce here. Okay,
Why 1 block?
because I have 1 block to write, because I have only 1. Okay, I have num, right? So num, and this is only 1, so I'm going to write. So I'm going to write that one, and then finally, but so there is this, basically this is the body of for loop, and so I'm going to do that in the 9 times, okay, with different n. And finally I'm going to close the fptr. Okay, so this is something. So let's consider that. Okay, I'm going to the first approach, writing to a binary file. This is the first approach, writing to a binary file. Okay, and then here a1, writing to a binary file. So as you can see here, now I have a file test.bin, but let's check that how much is the size of this file. Okay, so as you can see here, the size of this file is 108, right? But how much data I stored inside? So if we check the text, the file, the source code, the binary writing to a binary file. Okay, so I'm storing basically, okay, a value that it has 1, 2, 3, 4, and 5. So it has 5 characters, right? Okay, so, and each of them, so each time that I write to the file, so I have 3 of these values, so 3 5 characters, right? So because I have 3 inside of each struct, right? So 3 5, so it means 15. Okay, and 15 times. But here, so as you can see, I'm repeating this task for 9 times, right? And so 15 multiplied by 9, so I have 135. If I want to store this file in a text format, I need 35 characters inside. Okay, but here as you can see, I store it in a 108 bytes instead of 135 bytes. But okay, so as I said, so when you're storing a binary file, so maybe the space efficiency is better than the text file, but it's not the case. I mean, every place, but usually, so the binary file has better space efficiency. Okay, so let's move to the first approach, reading from the binary file. Okay, so this is the point, and most of the case is the same as before, but here I'm going to repeat 9 times, and so I'm going to reading. So I passed FPTR, so this is the test bin that I created before, but here I'm going to read from the binary file, and so okay, the size of the file, and each time I'm going to basically read one block, and so this is printing what is the output. So and I'm printing out the content here. A1 reading binary file, A1 reading binary file. Okay, so reading from the binary file. Yes. Okay, so let's reading from the binary file. Okay, as you can see that here, so the, when I was going to write to the file, so I started from the counter of the loop was 10,000, right? And so it was 10,000 and 3,000 because it's the 3 times of the n1 value, and then 3001, and so on. So you can see for the rest. So I have from 10,000 to 10,008. So the counter was is lower than 10,009. So but not including the 9. So here I have from the 10,000 to 10,008. Okay, and so this is the. So I read that basically. This is the content of the binary file. Is that clear?